Okay, I am Ernesto, and thank you all for coming today. And I'm working in the energy and water area of the Center for Water and the Environment. And as you can see, my research is going to be about interfacial reactions of wellbore system with saline brine from the Permian Basin. So I wanted to give a brief overview of what wellbores are, and then give a little bit about my planned experiment and what I've been working on recently. So wellbores are used to extract oil and gas. They are made of cement and steel. The issue that I'm trying to study is the integrity, which is the ability of these wells to isolate fluids from the surrounding environment. This includes production fluids as well as formation fluids. And doing some literature review, I found that the three high-level mechanisms for integrity failure is chemical, mechanical, and physical. So chemical being the most prevailing wellbore integrity issue in any condition. Mechanical is going to be a loss of integrity from changes in stress from the formation or changes in stress due to wellbore operations. And then physical causes of failure is how did they actually create this wellbore? Has to do with the pouring and drilling operations, and as well as the types of materials that they used. My research is going to focus mostly on the chemical failure. So the knowledge gap that I found is that there's just an increased need for what is going on in these wellbore environments. A lot of the published work that we have seen deals with the interface between the cement and the formation, cement fractures itself, and there's just a big gap for the interface between cement and steel. This is less studied, I feel, because it's an overlap of geotechnical and environmental engineering areas. I'm finding a lot of literature on electrochemistry as well as geochemistry. And hopefully this work can lead to quantitative data that would better calibrate some reactive transport models so that we can better assess the environmental impacts of these wellbores that we're using. I'm building off the previous work that was done here at UNM, which was a few years ago, and recently published a paper, and it dealt with saline brine in a cement fracture. And so moving forward, I'd like to include the steel interface for this knowledge. So the objective and hypothesis for my work is to determine the effects of saline brine on solubility and the reaction products at this interface and how those could affect the permeability and mechanical properties of this wellbore system. I'm going to simulate the conditions of elevated temperatures and use field sample water from the Permian Basin. So my hypothesis is that the saline brine will be highly reactive in this interface and cause the iron to be reduced and possibly other ions in the water to be reduced as well, and then oxidize the sulfur. And then my other hypothesis is that the formation iron precipitates will form on the iron while calcium precipitates will form on the steel. So I've been working on this conceptual diagram to help me better understand this research. So I've created a little diagram here, and you can see that this is my envisioning of the cement-steel interface. As you can see, what I've read in literature is that there often does exist a flaw in these, that the steel and cement are actually separated, and that's caused during the production or drilling of the well. So a little bit about the Permian Basin. This is a screenshot of the produced water app from USGS. This is not a picture of the wells. This is just the little dots are where they've taken produced water samples. There's quite a few wells in this area, and in this area has become one of the highest producing areas in the nation for oil and gas. So it helps me reinforce the idea that there needs to be some research done in this area. So here you can see a few water qualities that we've seen in this area. There's two main water qualities that have been categorized, either paleo seawater or freshwater influx to the formation. I'm still waiting to try and get my field sample water so that I can have a better idea of creating a lab water. Here you can see my experimental approach, quite the layout I've created for myself. So the first thing I've been doing is really trying to figure out how to pour all these samples and create this interface, which has been more than difficult, at least more than I thought it was going to be. I just pictured myself going in there and making some samples and being done with it. This is a really important step because this curing of the cement itself is trying to get a proper reaction. So you can see here I'm on my third mold that I've created. I had two other molds that didn't work out so well. You can see that these are the sample geometries I'm hoping to create. Here's my control samples. That way I can have this small space reaction with cement only and with steel only. So here's the results of some of my trial pours that I've done. I found that my first molds were too small at 1 inch diameter, and I broke them trying to get them out of the molds. So I moved to 1 1/4 inch mold and tried to pour 30 of them at a time, and the cement hardened before I could pour all 30. So as you can see in the previous slides, my newest mold is only 12. Hopefully much better luck with getting everything done. So thank you. Any questions?
All right, thank you, Ernesto. Good job. Any questions for Ernesto?
Yeah, I'm sorry. I have a really quick one. It seems like you're doing a lot of chemistry and whatnot. These sorts of failures that you're trying to examine, they happen over years or decades. Is that true? I mean, is that true? And if so, how do you condense that time frame in the lab?
So just what I've read so far, there is failure over the lifetime, but a majority of the failure occurs soon after the well has been completed.
Okay.
Have you seen any studies about how like the rise of microquakes from fracking have influenced like wellbore integrity?
I haven't seen any literature specifically to that. I mean, there is literature that any change in situ stresses could cause radial cracking in the cement or cause debonding of the cement from the steel.
I have a quick question. Great presentation. I was just wondering, has there been any research, or is soil chemistry where it's being emplaced at, is that a huge factor that will degrade integrity?
So there has been some work with the formation. Usually it's like cap rock or really, big formation rocks, because they're about 2 kilometers down. So I've seen some literature, and there is an effect, of course, on formation chemistry on the cement. But there is, I'm thinking there's a greater impact on the cement and steel interface than the cement to formation.
Cool. All right. Well, thank you very much, Ernesto.